Today we'll start Chapter 10, and Chapter 10 starts with parametric equations. Parametric equations are kind of a different animal than we've run into in math before. I think possibly you've run into them in physics. But a parametric equation is actually a set of equations where the x variable behaves according to a function using a certain variable, and often we'll be using t as our variable. And the y values behave according to a different function using the same variable, using t, where t is known as the parameter. Parameter is kind of a rule, so t is the rule maker. Whatever t does determines what x is going to do and what y is going to do. So let's take a look at this. Here we've got some parametric equations. X is going to behave this way, equal t squared minus 1, while y behaves this way, it is equal to t plus 4. So depending on what t is, well, that's going to determine x and y. Now, if t is negative 2, well, let's see, that'd be 4. 4 minus 1 is going to be 3. And y is going to be, let's see, negative 2 plus 4. If x were to be negative 1, I think we would get 0 for x, and we would get 3 for y. If x were 0, we'd get negative 1 and 4. If x were to be 1, we'd be back to 0, but up to 5. And if x were 2, we're going to have x being 3, but y would be 6. And so let's graph this thing. We're going to graph the values in this table. We'd start at the point 3, 2. Then we'd have the point x is 0, y is 3. X is negative 1 when y is 4. X is 0 when y is 5. And x is 3 when y is 6. And so what we'd have here wasn't real obvious by looking at this set of parametric equations, but we're going to have ourselves a side opening parabola. And on the upcoming slides, we'll talk about how it's important to describe the curve that you get. So this would be a side opening parabola. We'd want to know where it starts. We would want to know maybe what the vertex is, want to know the direction it's going, want to know where it ends, things like that. We'll see that in the upcoming slides. Now again, looking at this, you wouldn't look at this set of parametric equations prior to graphing it and say, hey, I know what this is going to turn out to be. It's going to be a side opening parabola. But we can turn this parametric equation, or set of equations, into an equation that's got nothing but x's and y's by eliminating the parameter t. And to do that, what we're going to do is we are going to solve this equation for t. T would equal y minus 4. And now what we're going to do with this is we're going to go back to the x equation and we're going to replace t with that value. So x is equal to y minus 4 squared minus 1. And now, let's see, I've got y squared. I've got minus 8y plus 16, but then we subtract 1, so it would be only plus 15. Now, looking at this equation, you recognize an x equals y squared is a side opening parabola that opens to the right. And I think we would. So that's how we eliminate the parameter to get it into x and y terms that we're more familiar with. All right. What if we have one that involves sine and cosine? Well, t is going to, we're going to be given an interval of t. So we'll start at 0. I really should have made this less than or equal to, less than or equal to. And then maybe we'll go to pi over 2. Pi. 3 pi over 2. And 2 pi. Now x is equal to the cosine of these t values. So if we know our unit circle, cosine of 0, cosine of pi over 2, cosine of pi, cosine of 3 pi over 2, and cosine of 2 pi. Now y behaves according to this value of p. And so the sine of 0 is 0, sine of pi over 2, sine of pi, sine of 3 pi over 2, and sine of 2 pi. Now if we come over to the graph and we graph this thing, we're starting at the point 1, 0. Then we go to the point 0, 1. Then we go to the point negative 1, 0. Then to 0, negative 1. And finally, right back to where we had started. Now, this is where we're going to learn to describe the motion. And the motion went something like that. So let's come down here and let's describe the motion of the particle. Where did you start? Shape of the path, direction, and where did you end? Well, I think we're going to say we want to start at point 1, 0. We are going to want to follow a circular path. Circular, there we go. Now, a very specific circular path. I don't want to say we're going to start at 1, 0, we're going to follow a circular path, we're going to end up right where we started. Because that could have been something that went like this. So we're going to follow a circular path with radius 1. And this can be worded different ways, but I just want there to be no mistake as to what the path of this circle is. Follow circular path radius 1, a large suspicious space, centered, this circular path is centered at 0, 0. Now, it's important that I go in this direction the whole time, and I better indicate that I want to go in that direction. So in this suspicious space, I think I'm putting the word counterclockwise. And now, does that limit me to exactly that red path? If we start at 1, 0, we follow a circular path of radius 1, counterclockwise, and this path is centered at 0, 0. I kind of think that's where we got to go, but now we have to say where we're going to end up. So ending at the point 1, 0. And I think that that would do it. Again, different ways of wording that. Now, if we were to eliminate the parameter, eliminating the parameter when you have x is equal to, and I think this was cosine of t, y equals sine of t. I think what I would do is whenever sine and cosine are involved, there's a trig identity that we're aware of. We're aware that cosine squared of t plus sine squared of t is equal to 1. Now, if I've got cosine squared, what can I replace cosine squared with? Could that be x squared plus sine squared is y squared? And I've eliminated the parameter t, and is this the equation of a circle centered at 0, 0 with a radius of 1? So whenever you're given parametric equations that involve sine and cosine, this is something to work towards. Oftentimes you're going to be squaring them in order to get your eliminated, your equation where the parameter's been eliminated. All right. This guy, can you graph that? Well, no, we can't graph x equals equations. But what we can do is we can turn this into parametric. If I say, all right, now I need a pair of equations. I need an x equals, I need a y equals equation. And if I say, well, let's see, I'm going to have y equal t. Now, if y is equal to t, then x is equal to t minus 5t cubed plus 2, instead of y, I'll say t to the fifth. And I've got the parametric equation. Now, how do we graph that on our calculator? Well, we've got to go to mode. And we've got to arrow down to where we see function, and next, right after functions. Instead of graphing functions, we're going to graph parametric. So I hope you have your calculator in hand, and if not, press pause and come back to this. So select parametric. And now, press the y equals button. When you press the y equals button, it's going to have x equals, and then when you press the x button, you don't get x's anymore. You get t's. And you're going to press the x button, you're going to get a t minus 5, and press that x button again and get t. Make sure you raise it to the exponent of 3, plus 2, t to the 5th. Y sub t is going to be equal to t by pressing that x button. When you go to window, when you're in parametric, you go to window. The first thing you see is T min. So you set the minimum value of T. Before we said T was going to go from 0 to 2 pi. Oftentimes you'll be told what values of T to use. You'll be able to set T max. You'll be able to set T step. Now T step should be small so that you graph a lot of points and you see a pretty accurate representation of what this is going to look like. I like to use T step of 1. And then you'll set your X min, your Y, or X max, X scale, Y min, Y max, Y scale. And you might even practice this by using something like this. So get your calculator into parametric mode and graph that guy. You know that your X max of 1, X min of -1 is going to be fine. Y min -1, Y max of 1 is fine. And you're told what T's are. So maybe practice graphing a parametric using this one. And once you've done that, I think you're on your way to working on the assignment that's posted in Schoology. Good luck.